In this class, we are going to go over motion graph. We are going to cover position time graph, velocity time graph, and acceleration time graph. Before we start, I want you to be familiar with two concepts. The first concept is slope. Slope is associated with division, okay? Slope is associated with division, okay? And the second concept is area, okay? Area is associated with multiplication, okay? Multiplication. I will explain those two concepts now. I want you to pay attention, okay? Let's say we have this motion time graph. We have the y-axis and we have the x-axis, okay? The y-axis and the x-axis. Let's say an object travels in this direction, Please pay attention. Let's say this is y1, this is y2, and this is this point also. This is y1, this is y2. Let's call this point x1, x2, x3. You understand? Okay. Now, when we talk about slope, I'm very sure you are well versed with algebra. Okay. In your basic algebra, we usually represent slope as what? M. You understand? Slope is usually represented as M, and slope simply means change in y all over change in x. You understand? Change in y, slope, which is M. Slope is equals to change in change in y rather, okay? Change in y all over change in x, which is what? y2 minus y1, okay? y2 minus y1 all over x2 minus x1. You can use any position along the graph to find the value of you can use any 2 points on the graph to find the slope. You understand? You can take x3 and x2, you understand, provided that the interval is the same. You understand what I'm saying? But I just use this as an illustration, okay, that slope is associated with what? Division, and area is associated with what? It's associated with multiplication. Now, if you are told to find the area, look at this. We have a rectangle here. The area of the rectangle is what? Length times breadth, and the distance between this point and this point is what? Change in x. Is that not it? Delta x. The distance between this point to this point is what? Delta y. Is that not it? That is change in y. Now, if you want to find the area is what? Product of change delta x and delta y. Is that not it? Because area of the rectangle is what? Length times breadth. Okay. So area is delta y multiplied by delta x, which is what? Delta y delta x. You understand? So area is associated with multiplication, while slope is associated with division. Okay, let's quickly talk about the position time graph. Let's say we have an object traveling along the x-axis. The graph will be x versus t. You understand? Please pay attention. X. Let's say we have the graph like this. If the object is traveling along the x-axis, the graph will be x versus t. Okay, you understand? Of course, it is possible for we to have an object traveling along the y-axis. In that case, the graph will be what? Y versus t. But let's just consider this as an example. Okay. Now, we want to look at the slope and the area of a position time graph. You understand? We want to check what the slope of a position time graph tells us and the area of a position that what it tells us. We want to check it out. Okay. Now, don't forget that I told you that slope is associated with what? Division. Okay. Slope is associated with division, and slope, let's represent it as m. M is equals to what? Change in x, that is change in else. In this case, all over change in t. You understand? Because the graph is now x versus t. It is not x versus y. Do you understand? Please pay attention. Now, for this, we are going to have d, where d is the displacement. You understand? In position time graph, we are dealing with displacement. Okay. x in physics is used to represent displacement. So for this, I'm going to have d all over t. Now, displacement, if this is displacement and this is time, now which concept in physics is used to describe displacement all over time? Displacement over time is used to describe velocity, you understand? So the slope of a position time graph will give us the velocity, okay? Please pay attention. The slope of a position time graph will give us the velocity. Now, let's talk about the area. Area is associated with product, you understand? And area now will be, let me put it like, okay? Let me check something here. Yeah. Now let's talk about the area. Area A is equals to the product of delta x and delta y. You understand? Please pay attention. Area is the product of delta x and delta y. And delta x is what? D, which is displacement. Displacement is measured in meter. You understand? And oh, sorry, it is not delta y, it is delta t, okay? Sorry. It is delta x, the product of delta x and delta t. Now, delta x, which is displacement, change in displacement, is measured in what? Meter. And delta t is in what? Seconds. That means I'm going to have meter multiplied by seconds, which is what? ms. Now, in physics, what does ms tells us? ms is nothing, you understand? Ms is nothing in physics. So the area of a position time graph tells us nothing, you understand? But the slope of a position time graph gives us the velocity, you understand what I'm saying? So that's it. Now, let's talk about the velocity time graph. The velocity time graph is a graph showing the relationship between the velocity of an object and its time. You understand? The velocity time graph shows the relationship between the velocity of an object and time. Now, let's say we have velocity time graph now. Velocity time graph. Okay? Don't forget that velocity time graph tells us the relationship that exists between the velocity of an object and the time. You understand? Okay? Now, what does the slope of a velocity time graph tells us? Don't forget that slope is associated with division. Okay? In this case, m is equals to what? M is equals to dv, the change in v, all over change in t. You understand? Now, what does the slope of a velocity time graph, what does it tell us? Well, let's check. Don't forget that velocity is, the unit of velocity is what? Meter per seconds, okay? So for this, I'm going to have meter per seconds all over, the unit of time is what? That is seconds, okay? All over seconds. For this, I'm going to have meter all over seconds divided by seconds over 1. Do you understand? Okay, for this, I'm going to have meter all over seconds multiplied by what? 1 all over seconds, which is what? Meter all over second squared. This is equal to what? Meter per second squared. Do you understand? Now, which concept is used to represent meter per second squared in physics? That is acceleration. Okay? Please pay attention. This is simple. Okay? I just want to establish the point that when we talk about the slope of a velocity time graph, the slope tells us something. And what does it tell us? It tells us the acceleration. Okay? When we take the slope of a velocity time graph, it tells us the acceleration, because acceleration refers to the change in velocity all over the change in time of an object. You understand? And I have proven this by making use of the unit. You know, the velocity is measured in meter per seconds, then and time is measured in seconds. So I just do some little calculation here, and I arrive at what? Meter per second squared. And the unit of velocity is what? Is measured in meter per second squared. Do you understand what I'm saying? So that's it. The slope of a velocity time graph tells us what? The acceleration. It gives the acceleration. Okay? Now, what does the area tells us? Area is associated with what? Division. Oh, multiplication, sorry. Area is associated with multiplication. So, area is equals to multiplied by delta t. You understand? Now, change in v is what? Okay, let's make use of units now. Okay, velocity is measured in the unit of velocity is meter per second. So I'm going to have meter all over seconds multiplied by the unit of time is what? Seconds. Oh, multiplied by seconds. So for this, I'm going to have this seconds will cancel this second. So I'm left with what? Meter. So therefore, the area of velocity time graph tells us the meter. Okay. When we take the the area of velocity time graph, that we arrive at what? Meter. Now, what unit? What concept has this unit in physics? That's what I want to ask. What concept has the unit? Has meter as its unit in physics? Meter is the unit for displacement. You understand? Meter is the unit for displacement, distance, position. But since we are dealing with velocity, we are going to get displacement. You understand? Because velocity is equal to displacement all over time. You understand? Those are the basic concepts that is very, very important. Speed is distance over time. You understand? But velocity is what? Displacement all over time. And we are dealing with velocity here. That means that the unit, the area of a velocity time graph tells us the displacement. Okay? When we take the area, we're going to get the displacement. Do you understand? Okay? Let's move to the third motion graph, which is acceleration time graph. Okay, acceleration time graph tells us the relationship that exists between the acceleration of an object and the time. Okay, what does the slope of acceleration time graph, what does it tell us? Don't forget that slope is associated with division. Okay, slope m is equals to change in acceleration all over change in time. You understand? And don't forget that the unit of acceleration is what? Meter per second squared. Okay, meter per second squared. So for this, I'm going to have meter all over second squared divided by, okay, so that you won't get confused. Okay, let me write it here. Let me just write it here. Okay, the unit of acceleration is what? Meter per second squared. So I'm going to have meter all over second squared divided by this division sign. This is it. The unit of time is what? Seconds divided by seconds. Let me just put s over 1. So let me erase this. You understand? Now, for this, I'm going to have, if you change this division sign to multiplication sign, the numerator here will become the denominator. You understand? So I'm going to have meter all over second squared multiplied by 1 over s, which is what? Meter all over second raised to the power of 3. Now, in physics, which concept has the unit as meter per second cube? You understand? Because this will give us meter per second cube. Meter per second cube. In physics, the term that has meter per second cube as its unit is joule or joule. You understand? Joule or joule. Joule or joule. Do you understand? Okay, that's the concept, that's the term that is used to describe the unit as meter per second cube. Most physics course doesn't contain this concept, hence you might not find it in textbook. You understand? So if you come across this in exam and you didn't find jack or jolt in the option, you can just choose nothing or none of the above. You understand what I'm saying? But the term that has the meter per second cube as its unit is jack or jolt. You can check Wikipedia. We're going to see it here. Okay, now let's talk about the area. What does the area of acceleration time graph tells us? Don't forget that area is associated with multiplication. You understand? Area is equals to the product of acceleration and time. You understand? So for this area, acceleration, the unit of acceleration is what? Meter per second squared. You understand? So for this, I'm going to have meter per second, which is all over seconds squared, multiplied by seconds. The unit of time is what? Seconds. Okay, so for this, I'm going to have seconds, we cancel 1 second, so I'm left with what? Meter per second. Do you understand? X squared is what? X times s. You understand? So this s will cancel 1s, so I'm left with what? 1s. That's why I have meter per second. You understand what I'm saying? Now, in physics, which term has its unit as meter per second? That should be velocity. You understand? The term in physics that has its unit as meter per second is velocity. Hence, the area of acceleration time graph tells us the velocity. Okay? Do you understand what I just did? The area of acceleration time graph tells us the velocity. Okay? That means if the area of acceleration time graph is the product of acceleration and time, area of acceleration time graph tells us the velocity. Okay, it gives the velocity. That means I'm going to have vf minus v naught is equals to a plus t, the product of a and t. You understand? That means final velocity is equals to at plus v naught, which is what? Vf is equals to what? V naught plus at. You understand? Which is one of the equation of motion. Do you understand? Now, let's say we have this position time graph. I pay attention. The line that touches the curve at exactly one point is known as the tangent line. Okay? You know, let's say we have this position time graph. This is the line. This is the curve. Okay? This is the curve. Now, if we have a line that touches this time graph at exactly one point, that line is what we call the tangent line. Are you paying attention? Okay? You can see that this line touches this curve at exactly this point. You understand? Please pay attention. This line that I drew touches this curve at point 2. You understand what I'm saying? This line is what we call the tangent line, and the slope of the tangent line gives the instantaneous velocity. You understand? The slope of the tangent line gives the instantaneous velocity in a position time graph. You understand? That is the velocity at an instant of time. You understand? If you want to learn more about instantaneous velocity, you can check the description of this video. You're going to see a link there. Click on that link, okay, to watch various questions on instantaneous velocity and acceleration. Okay, now let us proceed. The line that touches the curve at 2 points is known as second line. Okay, you know, I've talked about tangent line now. Now we are talking about another line known as the second line. Let's say we have another line drawn. I don't know how to do it, just pay attention. Okay, this is the tangent line. Okay, tangent line, tangent line. Now, let's say I have another line that touches this curve at this point. You understand? This is point 1 and this is another point. Do you understand? You can see that this line touches the curve at 2 points. That means that this line is what we call the second line. Second line. Do you understand? The tangent line touches the curve at exactly 1 point, while the second line touches the curve at 2 points. You understand what I'm saying? The slope of a second line gives us the average velocity. You understand what I'm saying? You can see that this the second line touches the curve at exactly 2 points. That is at point 1 and at point 3. You understand? So the slope of a second line gives the average velocity. Now, how do we calculate the slope of a tangent line and the slope of a second line? The slope of a tangent line can be calculated by taking the derivative. You understand? That is calculus. From a basic calculus, you can use the general formula to find the derivative of the function that you are given, and you insert the time at that particular point. You are going to get the slope. Do you understand? So the slope of a tangent line can be gotten by taking the derivative using calculus, but the slope of a second line can be gotten by using algebra. You understand? You can get the slope of a second line using algebra. You know, if you remember very well, when I start this class, I said that slope is associated with what? Division. You understand? And slope is what? M is equals to y2 minus y1 all over x2 minus x1. But because this graph is this graph is a position time graph, and the movement is along the x-axis. You understand? So for this, we are going to have what? The slope now becomes x2 minus x1 all over t2 minus t1, because the graph is now x versus t. Do you understand what I'm saying? So that's it. You can get the slope of a second line using algebra. Okay, that will be all for this class. To watch the next class, kindly check the description of this video. Okay, don't forget to like, comment and subscribe. Okay, see you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.